So, hello, welcome to my presentation. This is the my project on the weather conditions and the climate change. So, my name is Gautam Radhakrishnan. So, starting with the project objective and the data sources. So, as a hypothetical data analyst working at ClimateWins, the aim of this project is to explore whether machine learning methods will be able to predict weather patterns across mainland Europe. So this data was recorded and collected from 18 different weather stations across Europe. Different features such as wind speed, temperature, humidity, precipitation, snow depth, etc. are recorded. And these values have been recorded from the 1800s to 2022. So some of the questions we would like to explore through this project is how is machine learning used and is it really applicable to weather data? Do different machine learning techniques yield similar results or different ones? Can machine learning really be used to predict whether weather conditions will be favorable and explore how the performance of a model can be improved? So we'll start with the first model. This is the K nearest neighbor algorithm model. So on testing this model with just one neighbor, the training accuracy was found to be 100%. But the performance on the test data was disappointing, which basically means the model was overfitting. And as I increased the number of neighbors, the results became less and less impressive. Out of all the weather stations, Sonnenblick recorded 100% test accuracy. Another station, Valencia, recorded 96%. The average accuracy of the model was measured to be 88%. So looking at the training accuracy, when the number of neighbors was 1, we found it to be 100%. But as I increased the number of neighbors to 2, 3, and 4, you can see that the training accuracy really dropped. But the test accuracy is also not very impressive, all the while keeping below 50%. Now moving on to the second supervised learning model, which is the decision tree. So the decision tree achieved a test accuracy around 55%, and the training accuracy was only 60%, which is much lower than the KNN model. Here too, some of the results were common. For example, the weather station Sonnenblick recorded 100% accuracy on the test data. So this is the decision tree that was generated. The labels are not very clear. And as you can see, there are so many branches, and this decision tree, if pruned, could lead to better results. Now moving on to the most complex model, the third model, which is the artificial neural network model. So this is a slightly more advanced model than the other two. So the first model had 2 hidden layers of 5 nodes each. And this model was run for 500 epochs with a tolerance of 0.00001. And this model performed very poorly with both the training and the test accuracy with only around 41%. To improve the model, another experiment was conducted. An additional hidden layer was added, and the number of nodes also was increased. Like the first hidden layer had 100 nodes, the second hidden layer had 50 nodes, the third had 25, and this was run for more number of epochs, around 2000. This model achieved a much better training accuracy, 75.11%, which is, although it's still a bit lower than the KNN model, it it had a better test accuracy score of 56%. So the KNN model records the highest training accuracy among all the 3 models with 88%, but the test accuracy falls below 50%. So this is a sign of overfitting and hence cannot really be recommended for this data set. The ANN, although it started out with poor results, while After tweaking the hyperparameters, was shown to yield better scores than the other models. Pruning the decision tree is another experiment which we could consider to improve the performance of the decision tree model. Now, discussing some potential ethical concerns. Privacy on an individual level is not really an issue, as personally identifiable information is not really collected while collecting weather data. Some of these European regions may be less developed and data may not be accurately captured. Since we have data from the 1800s, the data pertaining to previous centuries may be less accurate due to underdeveloped instrumentation and recording mechanisms. Also, not all governments will be open to sharing the data publicly and may filter out data which could potentially show them in a bad light. This could affect the integrity of any study conducted on the data. Thank you.